We'll proceed in the volume calculation of hemisphere that we have been talking about, and then we'll proceed in similar fashion for the surface area. So volume and surface area in cylindrical coordinate alternatively. Water tank, you are amazing, you are awesome. So if I have a water tank is in shape of water tank is in shape of hemisphere. Hemisphere. Okay. If I cut it, if I cut it here, okay, if I cut it here, then this portion is half sphere. If I cut it here, if I cut it here, then if I take this top portion, then it will be half hemisphere. Okay, I'm not considering this as sphere, but still you can see the shape from here. From here, it looks like a sphere which ends somewhere here. If I cut it from here, then this portion is half of the half of the hemisphere. So that is the idea. Okay, don't worry. I won't show that up again. I have better sphere. Okay. So idea is if I cut it at the half, okay, this is a sphere, and if I cut it exactly at half, okay, if I cut it, then the top portion, okay, okay. So if I cut it exactly in the half, okay, so the top portion will be kind of hemisphere. Top portion will be hemisphere. If top portion is hemisphere, if top portion is hemisphere, then what is the volume of hemisphere? So I have a water tank. I have a water tank, normal water tank that is lifted. So at my home there is a water tank. I don't have any home, but whatever it is. Consider that I have a house, and on top of it there is a water tank. And now water tank, generally people find water tank that is cylindrical in shape. Nowadays, cylindrical in shape, but big water tank, when you see, that will be still, they will be hemispherical shape. Means if you have a sphere, you cut down at the center, bottom half you throw it away, and top half is the water tank. If top half is the water tank, then if I fill the water in the water tank, and if it is filled, then what is the volume of the water? The volume of the water is half of the sphere volume. So sphere volume is 4 pi aq. A is the radius of the sphere. 4 pi aq divided by 3. If hemisphere, that 2 pi aq divided by 3. But consider that water is filled at a moment, it is at height h, small h. Then what is the volume of the water? That is the question. If that is the question, then answer is not easy. We need now algebraic equation, and then we need calculus. Calculus is nothing but if I have rate of change, calculus calculate the collection. Calculus is nothing but addition. Finding addition through calculating the area. If person is running 5 kilometer per hour, then his collection is every hour he is collecting 5 kilometer. At the end of 2.5 hours, how much he has what? How much he has collected. If there is a x-axis, there is x-axis that is time. X-axis that is time. And y-axis is function over time. X-axis is time. This is how algebraic equation is. Calculus algebraic equation. If x-axis is time, then y-axis is function over time. If that is the case, then y-axis is 5 because it's constant. Vertical is 5, it's constant. I say ft equal to 5. How much he has worked till 2.5 hour? Then 2.5 hour, what is the area? That much he has worked. That is the addition. Okay, 5 plus 5 plus 5 and half. Means I actually am asking to calculate the simple addition. If I want to calculate the simple addition, then this is how it is 5, 5 and 5 by 2. If that is the case, that addition can be brought in into the picture if I draw a FT and then I try to get the area. That is 5 into 2.5. That is the area. Width into height. That is the area. But this width into height I have taken for rectangle, but if I go ahead and try to calculate area of any algebraic equation, that will give me the summation. That is the beginning of new concept that is called finding area. Integration is a kind of terrific name. Means you terrify someone saying calculus and integration. Actually, it is nothing but calculating the calculating the addition while you do the calculation of the area. If you do the calculation of the area, then that is the addition. If I say that a person is walking in sinusoidal way, means at the beginning his speed is 0, but when he is reaching pi by 2, pi by 2 radian, pi by 2, at that moment his speed is 1 kilometer per hour. But when he goes to pi distance, then again pi distance, then again his velocity is 0. But if he goes to 3 pi by 2, then velocity is minus 1 kilometer per hour. Then he goes to 2 pi, then his speed is 0. How much distance he has walked? That is nothing but area he has walked. So one is area is positive, another same area is negative, means he did not walk at all, but anyone would quarrel, right? How much kilometer he walked? Certainly he was walking. Okay, at one time he reached 1 kilometer per hour, then he took rest at pi, then again he started walking and minus 1 kilometer per hour his speed, again he came to rest. How he did not walk? But integration shows that net kilometer he traveled is 0. This proves that person was walking, he went till some location and he came back. Negative means direction is opposite. So anyway, how much he has walked from 0 to pi is the area. So area is nothing but the integration. This is how we are calculating nowadays area. So sin x area is cos x. Integration of sin x is minus cos x. If that is true, then cos x and from 0 to pi, 0 to pi. So pi is minus 1, 0 is again 1. So minus 1 minus 1 minus 1, 2, minus outside, gone. 2 kilometer he is walked. So nice, right? Means no one can calculate because if his speed is smoothly changing, every moment it is changing. The way algebra, calculus is not infinitesimal small. That's it what we take. If someone has to ask integration, he will make a small strip and this is delta x and then this is the height and consider that at that moment sine curve is like a flat. Don't do not required. Okay, it is pure area. If you have sin x, then its integration is cos x minus cos x. How it is, that you have to check, because sin x can the polynomial equation of sin x is something, I believe 1 by x plus 1 by x factor, whatever. So based upon that, breaking, they, when they think that it has come to their control, then they get the integration and they see it is exactly like cos x. We will see that how we calculate the integration of sin x. Okay. So this is how the integration. Integration means addition that is calculated through calculating the area. If we are trying to calculate the volume, if I have independent component as xy plane, xy plane is an independent component, not x-axis or y-axis. On xy plane, if I have a function on xy, fxy, that function will be a surface because xy point is not on a line, it is on surface. Okay, I believe it should be understandable. So if this is a xy plane, if this is xy plane, then xy point will be everywhere on this plane. For each xy point, I have fxy. Fxy. If I connect all the points of fxy, it will generate a surface. If I calculate the integration of if this surface area from this location to this location, then it will constitute a volume. Okay, so if I have surface area, so if I see x 2 points, then there is 2 points in x, but xy plane if I see, then there will be 4 points that will confine the anything. If I take 4 points and try to get the area, that is nothing but volume. So integration of in 2D or integration of a line gives me area of a surface. Integration of a surface gives me the volume. Now, the concept is that if I have a hemispherical water tank, and if I try to find the volume of the water tank, then it is nothing but integration of the fxy. So if this is the surface and this is the hemisphere, then whatever the fxy, that the surface fxy equation is, if I integrate it, it will give me the volume. So what is the fxy? If I consider this xy plane as r theta plane, that is in, we have done it in cylindrical coordinate system already, so you can check it. So for the spherical coordinate system, again we have done in r theta plane. So if there is a r theta plane, okay, if there is a r theta plane, if there is a r theta plane, then function over is f r theta. If function over that is f r theta, then what is f r theta? If I have a hemisphere, consider top portion only. So I have hidden the bottom one. So whatever you seeing, that is the hemisphere. Now, if the base of the hemisphere, if I cut down, then the radius is a, that is the radius of the sphere. But if top portion somewhere if I cut, again it will be a circular region. That radius will be smaller to the radius of the sphere. So that radius, if I consider r and a sphere radius is a, and at height we want to calculate the water content, then height is nothing but f r theta fxy. That is a function over the r and theta. If this is r theta plane, then vertical is, that is nothing but f r theta. So vertical is h. So h equal to a square minus r square at that moment. R square a square. So a square minus r square. So now f r theta is a square minus r square square root. This I have to integrate from one limit to other limit to get the area. Integration in the plane of r theta. So now we have square root of a square minus r square r d theta dr. That is the area in a in a r theta plane, polar coordinates. So now it comes as r by square root of r into square root of a square minus r square dr d theta. Where r, now r, if you see, if I am taking okay, this is r theta plane. If this is r theta plane, then this is hemisphere. If this is hemisphere, water is at this level one. Now water is at this level means water is not touching the any portion of the hemisphere. But when it goes little right, there it touches the hemisphere. From there to down, hemisphere is like this. Water is like this. At one portion, it is touching the hemisphere. This side, this side, this side, this side, everywhere. So where it touches the hemisphere, from there, what is the volume? And then if we just leave the water region that it is not touching the hemisphere, then it is a cylinder. In middle, it is a cylinder, otherwise it is touching the hemisphere. So we can calculate the volume of the hemisphere where water is touching the surface, that that volume. For that, the radius will be the location. If this is hemisphere, if this is hemisphere, and here it is touching the water is touching the hemisphere, this location to the end location. So that is the hemisphere region where water is touching it. So what is this? What is this much? From here to here. So end is radius A. And what about this? Okay. So if I talk in H, this is R. I had taken a cross section on top. This is R. This is H. And hypotenuse is A. This is R. If I talk R in H terms, then it will be A square minus R square. I'm sorry, A square minus H square. So the radius, if I say I'm calculating, then R into a square root of A square minus R square dr d theta integration R is from a square root of A square minus H square till A. That is the volume of water that is touching the sphere surface. And what about theta? So theta is full 2 pi. Now if that is the case, then we can try the integration. So integration of r square root of a square minus r square is nothing but, okay, minus 1 by 3. This is what we saw, minus 1 by 3 and then a square minus r square to the power 3 by 2. If I differentiate this a square minus r square to the power 3 by 2, it will come as 3 by 2 a square minus r square 1 by 2 minus 2r. Minus minus gone. Okay, 2, 2 and 2 gone, 3, 3 gone. So it comes as r square root of a square minus r square. So integration is minus 1 by 3, then in braces a square minus r square to the power 3 by 2. If that is the case, then now we have to set a square root of a square minus h square to a. If I place a, then it is 0. A square minus r square is 0. But if I place a square minus h square square root there, it will turn up into h square to the power 3 by 2. It will turn up into h to the power 3. Minus will go away because this is lower limit. So it will turn up h to the power 3 by 3. This is the volume of water that is touching the surface region. What about the middle portion of the water that is not touching any surface? That is a cylinder. If that is a cylinder, then the volume of a cylinder is pi r square into height. Height is h and pi r square. So pi r is a square, radius of a sphere, minus h square. So if this is hemisphere, base of hemisphere, and this is hemisphere, then there is a radius of the hemisphere or sphere is a. If water is filled at till height h, then it makes a triangle where the at h the cross sectional circle, the radius is r, a and h, r, a and h. If this cross sectional is at height h, if h is 0, then we are making cross section of the sphere at the center. So r is a, but there r is r and there is a height, and that is radius is a. A square equal to r square plus h square. That is the concept. Now I am trying to find out the volume. So if there is a water at level h, then water is independent. It is not touching any surface of the sphere. But at one moment, at r distance, it will touch the sphere and there will be water all along. That volume is h to the power 3 by 3. What about the middle portion of the tank where water is there? It forms a cylinder. There the volume of the water would be pi r square h. R is nothing but a square minus h square root. So pi and in bracket a square minus h square into h. So pi a square h minus h to the power 3. Okay. So pi r square h. So pi and a square minus h square, a square minus h square, and then height is h. Okay, then it will be pi and then a square h minus h to the power 3 plus h to the power 3 by 3. Okay, now if I do this, then it will come as pi and then in braces a square h minus 2 h to the power 3 by 3. I believe so. This is correct. So 2h to the power 3 by 3. Okay. So that is the kind of uh, integration that we are seeing. Not correct. Okay, we'll go back with the previous integration that we calculated for the touching region. Touching region was minus 1 by 3 a square minus h square to the power 3 by 2. Integration square root of a square minus h square a square. A if I put then full 0. Now if I put a square minus h square, then it will be h to the power 3 by 3. Okay, now we did not integrate that theta. Theta is 0 to 2 pi, so 2 pi. So it is 2h to the power 3 by 3. Pi 2 pi h to the power 3 by 3. Now here it is pi a square h minus h to the power 3. So pi a square h minus h to the power 3 plus pi 2h to the power 3. Okay, if I add everything, it will come as pi a square h minus h to the power 3 by 3. Now it is correct. Okay, so here minus h to the power 3 and plus 2h to the power 3. This will come as minus h to the power 3 by 3. So pi and in bracket a square h minus h to the power 3 by 3 is the volume of water. Can someone think more ways? Okay. Now, if I see dv, this is we calculated through integration can be in two ways. This is our integration where we do fr theta fxy and calculate the integration through the volume. We calculate the integration through volume. But generally in book people would find that if I have a sphere, if I have a sphere, then inside the sphere there is a small sphere I will take and volume is dv. So in a sphere, very small sphere, I will take volume in name and its volume is so small, it is delta v. Delta v. Delta v has now, it has three independent components. Okay, delta V has three independent components. Delta V, what are the three independent components in a spherical coordinate system? What we are trying to do? We are trying to calculate the water volume through two coordinates, through two integral way in spherical coordinate system. One integral way is a normal integration way. Generally, it is means traditional integration. What is traditional integration way? Okay, so what is traditional integration way? So traditional integration way is fxy, that fxy you have to calculate the integration based upon the xy plane. But there is another way people they try to find dv. dv means a small volume, and that volume they will make kind of generalize it to the full sphere. So if I see dv is very small, then it is at Now, what is three coordinate, three independent components in spherical coordinate system? So, spherical coordinate system, if I have a sphere, if I take any point in the sphere, then it will be on xy plane or theta plane, it will be at angle theta. It will be at angle theta, and it will have radius a. I mean, it is very big. It will have a radius a. It will be angle theta. Theta is 90 degree. It is 0 degree. It is at angle theta, and then it is radius is a, and it is making phi angle with the perpendicular. If these three components are there, then inside the volume, any point uniquely I can I can I can denote. Okay, any point I can represent inside the sphere, okay, with these three independent components. These three independent components are orthogonal to each other. Why they are orthogonal to each other? If there is a phi angle from the vertical, if phi is making changing, then it is making an arc. This radius is perpendicular to the arc. So these two are orthogonal to each other. Can we find third orthogonal that is orthogonal to these two? Now, if there is a xy plane, in the xy plane, if there is a theta angle that is moving, then if I see the arc, this arc and this arc are perpendicular to each other. Radius is perpendicular to this arc also, and it is perpendicular to this arc also. So three orthogonal components are possible in a spherical coordinate system. So if I have a dv volume anywhere inside this sphere, then this volume is at phi degree from the vertical, theta degree from the horizontal, from the in xy plane, and it is at r radius. Okay, if r radius goes beyond and touching the sphere surface, then it becomes a. Okay, if r radius, if this is dv, this is full sphere, inside the sphere somewhere there is a dv, then from center it is r. If r goes beyond, it will touch the sphere and it will become a. That is the radius of the sphere. If dv is here, it is making phi angle from the vertical, and little bit it is rotated, so it here in horizontal xy plane it makes theta angle. So dv is at theta, phi and r, where phi can go from 0 to 2 pi, sorry, 0 to pi, and theta can rotate full 2 pi, and radius can go from 0 to a. Now, what is dv? Any volume has three, any volume has three sides. So one side is one arc, another side is another arc, and third side is the radius. So one, if it is r, then it is r sine phi. If this is phi, then r sine phi falls on the xy plane. If r sine phi falls on xy plane, then this arc is r sine phi d theta. Another is r phi, r d phi. If this is phi, then r d phi is this arc. This arc is r sine phi d theta and dr. So dv is nothing but r sine phi d theta, r d phi dr, or r square sine phi d phi dr d theta. So that is the dv. Now this dv, I have to do triple integration because all three now they need the integration. So r if I take 0 to a, theta if I take 0 to 2 pi, and phi I take 0 to pi by 2, only pi by 2, then it gives me volume of hemisphere. Can be calculated. So dv is now changed into r square sine phi r square, then I would say r square dr sine phi d phi and d theta. So r square dr is nothing but r to the power 3 by 3. Now r 0 to a, so a to the power 3 by 3. Sine phi integration is minus cos phi 0 to pi by 2 minus gone 0 1 1. So now it came as a to the power 3 by 3 theta 0 to 2 pi. So 2 2 pi a to the power 3 by 3 is the volume of hemisphere. If I had taken phi from 0 to pi full, then volume of the sphere. Now we are trying to calculate the volume of hemispherical. I have a hemisphere. Okay, if I have a hemisphere, then and inside that there is a water, hemisphere. Okay, understandable, right? So if I cut it half, if I cut whatever you can see above is the hemisphere. Okay, so if I have a hemisphere on a surface and there is a water till height h, then what is the content of the water? Now, for the content of the water, the phi, phi is, it is going, and it is touching a point where the water is. At level height h, the water is. And then phi goes till pi by 2. So phi is from this location where water is, this is what is varying. And then it goes till the kind of pi by 2. So phi is, is the catch here. Okay. Now if this is the case, then we will integrate this phi from that point to the end, and then radius 0 to a, and then we will, it's really difficult, and then 2 pi is the theta. Now phi, so if I do this, so let's take radius, I don't know, I believe radius is 0 to 0 to a. Okay, so phi is, now phi is in question mark. So it is again r square by 3, then it will be a to the power 3 by 3. Okay, now let's take the sine phi integration is minus cos phi. Now cos phi, this angle, whatever is this angle is till pi by 2. So if I say cos phi lower limit is this angle and pi by 2. So cos pi by is 0, and minus, then minus gone. Cos of whatever this angle is. So this angle, if I do the cos of this, then it is nothing but base by hypotenuse. That is h by a. That is the cos theta, right? H by a, that is the cos theta. So that will come as h by a. I believe I am correct. So this will, that phi, if it is phi is 0, then it is h by a is 1. Okay, that's why it is 1. But phi is at some angle, then the h by a. Okay, so it will come as h by a gone, cut, then it will come as a square h by 3, a square h by 3. Okay, a square by 3. Now h by a gone, a square h by 3 into 2 pi. So it will come as 2 pi 2 pi 2 pi a square h by 3, 2 by 3 pi a square h. Someone can try this. Okay, what is the volume we have calculated? That's we have to see. What volume we have calculated, that we have to see. Okay, now if I have a hemisphere, if I have a hemisphere, if this is r theta plane, this is xy plane, and there is a hemisphere, and in hemisphere phi I have taken from here because water is touching here to here. We have calculated the volume from here to the base. What is remaining is this portion. This is a cone that is remaining, that we have not calculated. From where, if this is hemisphere and this is water at height h, water is touching the hemisphere. That point till pi by 2 we calculated, and this region is the we calculated. But what region we have left is like this, that is a cone. If this is a cone, then the volume of the cone is pi r square h by 3. This is what I remember. I don't know. I don't remember much. But this is pi r square by pi r square into h by 3. So r square is nothing but a square minus h square. This is what we have seen. So it is now pi a square minus h square divided by 3 into h height. So pi r square pi by 3 or pi, okay, and then in braces a square h minus h to the power 3 by 3. This will get added to the another one, that is 2 by 3 pi h to the power 2 by 2 pi by, I don't remember what we said. So there the integration what we saw was that I believe a to the power 3 by 3 into h by a into 2 pi. So 2 by 3 pi and then a square h, 2 by 3 pi a square h there, and here we got pi and in braces a square h minus h to the power 3 by 3. Now if now we have to move and we have to add with pi to a square h by 3. If that is the case, if we add, it will exactly become like pi and in braces a to the power 3 minus h to the power 3 by 3. Okay, I never tried this, but I thought this is the concept. So pi the volume of the cone is what we are trying to calculate. The other portion of the volume, okay, other than this cone, the water touching the surface in conical region, that is 2 by 3 pi a square h, 2 by 3 pi a square h, and here it is pi and then a square h minus h to the power 3 by 3 or pi a square h by 3 minus h to the power 3 by 3. If I add this with pi to a square h by 3, then directly it will get added to the a square portion. So pi a to the power pi a square h minus h to the power 3 by 3. So this is the volume of the water that we calculated through all the means. So we can calculate, these are not available anywhere. So this is the way, so many ways we can use. If you remember, then in cylindrical coordinate system, when we did this calculation, in cylindrical coordinate system, when we did this calculation, okay, at that moment we did in a way that dv, we went again with the two ways. One is dv and one is integration of the fr theta. So dv in cylindrical coordinate system was r d theta, that is the surface r d theta dr dz, r d theta dr dz, where the volume. Okay, so if I take kind of, it's crucial, right? Means we are calculating the volume. Okay, let's, if before we proceed, can we try in Cartesian coordinate? At least we can make some progress. So in Cartesian coordinate system, if I try fxy, and then what is fxy? So fxy in Cartesian coordinate system is x square plus y square plus z square equal to a square. That is the surface of the sphere. So z equal to or fxy equal to square root of a square minus x square minus y square. Now I have to integrate that one in the xy plane. So square root of a square minus x square minus y square d of the area xy plane means dx dy. Okay. Now in that I have to take the integration of the x and y. So x, okay, if I have to see the x where water is touching the surface from that location to the end location. That is the x. Okay, y also we have to take in that fashion. So that will be the volume of the water that is touching the surface, and then cylindrical region we have to calculate. Someone can try this. This is function. This is the function over function through function we are calculating the volume fxy dx dy. Through dv also we can calculate the volume. So dv in Cartesian coordinate is dx dy dz. If that is true, then we have to go with the triple integration. So triple integration, again we have to see the z is from 0 to h, because we want only height h, the water level is 0 to h, and then x again from water is touching to the full. So this way we can calculate the volume of the water, and in center then we again calculate the cylindrical region. So better than Cartesian, I think cylindrical coordinate system and spherical coordinate system is better in this fashion. But someone is kind of enthusiast, then he can calculate through that way. So if I say first way dx dy, and then square root of a square minus a square minus x square minus y square, first integration with respect to x, then x, okay. So the water level, that is the radius r, it is at r, and then from there till end. So x, the x, earlier x was minus a to a, that is for the full hemisphere, minus a to a, okay. Now x is in two parts, minus a to a location where it is touching the surface, again location it is touching the surface, to a, where it is touching the location, what is x there? That is a question. Okay, so if I have height as h, then what is x? If I know the, it is a, so again it is a square minus h square, a square minus h square, square root to a, that is the integration. So now the integration is square root of a square minus x square minus y square dx, and limit is square root of a square minus h square or z square, whatever, a square minus z square to a. If I get that, then I have to multiply it by 2. So left side also we get it. Same we have to do this two sides, and then we get the volume of the water, and that is in Cartesian coordinate system. Anyway, we will see it. Next is that we have to find the surface area of a hemisphere, where hemisphere we cut at the height h. If I have a hemisphere, base is okay. If there is a hemisphere, it is not going full dome. In between, I cut it and then I cover it with a steel. Right side, full side is steel, and at height h, I cut it the top portion like a Meru mountain in Tanzania. So Meru mountain is like a hemisphere. There is a ground and there is a hemisphere, but top portion is cut because it is a volcano. So the kind of the top portion where the volcano is there, it is a flat. It is not the peak. Okay, this is not a normal peak like any mountain has a peak. It is cut because of volcanic eruption. So that cut. So how much is the steel that need to take to cover the Meru mountain? If I need to cover the Meru mountain with the steel, then how much it will take, and top portion if I cover it. So that we will see. There are many things. It's a another why we are pushing this much time in the coordinate system and interoperability is it will come to like a big blow if we are in, because this much complex calculus has come because we are inside now artificial intelligence and machine learning. So in those scenario, if we start with the Cartesian coordinate system, this is typically anyone would start trying. So in that fashion, if we start Cartesian coordinate system, then time will come when we will have tons of equation and then integration and we cannot solve. But if we know that some portion, this portion, that some portion can be handled through polar, some portion can be handled through cylindrical, some portion can be handled through spherical, then life will be easy. So thorough understanding of coordinate system is must, not required. Must. It is must. So when we calculated the water volume in cylindrical coordinate system, where a sphere is following cylindrical coordination, this is what we have seen. In that case, if I take a cylinder, the cylinder has a base. Cylinder. If I take a cylinder, if I take a cylinder, then cylinder has a base. Cylinder has a base and it has a height where everywhere this circle. So if I have a circular region and pile it up, then it makes a cylinder. So in cylinder, the variable, the independent component is theta. Okay, theta, radius, but radius is not like a sphere everywhere it is moving in. Okay, radius in only r theta plane, xy plane, there only radius works, because everywhere if I go in height of the cylinder, everywhere radius is same. Cross section, if we make cross section, everywhere circle is same. Now if I see dv, then it is r. If at the base if I calculate area, if it is r d theta dr, then there also it is r d theta dr. If that is the case, then the dv is r d theta dr and then dz, that is the height. So the dv, the volume of any dv in cylindrical coordinate system is the height of the volume, that is dz, and that then area is from r distance, if it is there, then r d theta dr. Understandable, right? So if this is a circle and if I take a small portion as area, if it is from r distance here, then arc, this arc is r d theta. If it is r is a, then it is hitting the full circle. If it is r somewhere in between, then r d theta is this r. If theta is 2 pi, then it is full circumference, r 2 pi, 2 pi r. But if it is theta, then r d theta. This is the arc, and this portion and arc portion and radius portion, these two make the any small area two parts. Now in that, then dz. So three portion is dz into r d theta arc and dr. So dv is r d theta dr dz. If that is the case, then we went for kind of dv, integration of the dv, and then that is what we calculated. So dv is r d theta dr dz. Okay, if that is the case, then r, the r we are taking. So now we are calculating the hemisphere in cylindrical coordinate system. Then the r is, I cannot take 0 to a, because r is, if you go in the height, then this r is reducing as per the hemisphere. If there is a hemisphere, then r will keep reducing and it will go to 0. Okay, so r is in function of h that we tried. So r will grow from 0 but not till a. It will go till h, it will go till a square minus h square square root. So if I cut this sphere at any portion, then we have many times we have talked. So there is a radius r, then height h, then this is a of the sphere, then r is nothing but a square minus h square. So r d theta dr dz, r dr, now it is r dr d theta dz. Integration is from 0 to square root of a square minus h square. So r becomes r square by 2. R square by 2. Now if we do calculate the limit, then it will become a square minus h square. A square minus h square by 2. A square minus h square by 2. Okay, so that is the kind of the limit integration r square a square minus h square by 2. H, I had taken height h. Consider z, that is the variation. Instead of h, it is z. So a square minus z square by 2. Now d theta, theta is 2 pi. So 2 2 gone, pi, and then a square minus z square. So pi, if I keep outside, then a square minus z square dz is the integration, where integration is from 0 to h. So z, a square z minus z to the power 3 by 3. Limit is 0 to h. So it is pi and in braces a square h minus h to the power 3 by 3. So this is very simple. If I go with the dv, so if I go with the dv, then through cylindrical coordinate system, we can calculate the volume of a water that is at height h. Many ways we have tried. So we'll go with the surface area of a sphere, okay, and then probably then we will wind up this discussion that is going on for long time. So that is nothing but the kind of cut various kind of coordinate system. So that we will see.